When troubleshooting electrical issues, it's important to follow a systematic approach before resorting to cutting open walls. The amount of time you spend troubleshooting depends on the complexity of the problem. Generally, you should firstly verify the circuit breaker or fuse to ensure it hasn't tripped or blown. Secondly, check the connections at all receptacles, switches, and junction boxes. Thirdly, use a multimeter to confirm power flow and continuity. If these initial steps don't resolve the issue, then consider further investigation, but within a reasonable time frame, perhaps 1 to 2 hours. Now, let's talk about cutting into walls. For sheetrock, the recommended technique is to use a utility knife or drywall saw. Carefully score the sheetrock surface and then snap it along the score line. Always wear safety glasses to protect your eyes from debris. If you're dealing with other wall surfaces like plaster or tile, the approach may need to vary. It is best to consult with a contractor or use specialized tools designed for those materials. Before you start cutting, always take safety precautions. Use a stud finder to locate the studs within the wall. Also, check for the presence of wires and pipes using a stud finder or a metal detector. When making your cuts, try to cut perpendicular to the studs to minimize damage. If you have to cut near wires or pipes, proceed with extreme caution. If you're uncomfortable with the situation, it is always best to contact a qualified professional. Regarding your choice of tools, a utility knife is ideal for making precision cuts in sheetrock. A drywall saw is more efficient for larger cuts. A sawzall can be used, but it is less precise and can easily damage studs if not handled carefully. After you've accessed the wiring, you'll need to repair the wall. Patch the opening with a piece of sheetrock that's similar in size to the hole you created. Use joint compound and tape to smooth the patch and create a seamless finish. If you want a professional-looking repair, especially on textured walls, it is best to hire a sheetrock or texture specialist. Finally, let's address the issue of charging for troubleshooting. It is generally a good practice to charge for your time and expertise, even if you don't resolve the problem. However, you might consider waiving the fee in certain situations, such as when the customer is on a tight budget or the troubleshooting was a relatively minor issue. Electrical troubleshooting requires a methodical approach. Before making any cuts, ensure you firstly isolate the power supply to the circuit you are working on by switching off the appropriate circuit breaker at the main electrical panel. Secondly, visually inspect the circuit breaker for any signs of damage or wear. Thirdly, use a non-contact voltage tester to verify that the power is indeed off at the receptacle or switch you intend to work on. Remember, even if the breaker is off, there could still be residual voltage in the wiring, so always double check. Now let's delve deeper into using a multimeter for troubleshooting. Firstly, set your multimeter to the appropriate voltage range, typically 120 volts AC if you are working on standard household circuits. Secondly, carefully insert the multimeter probes into the hot and neutral slots of the receptacle. A reading of approximately 120 volts indicates that power is reaching the receptacle. If you get a reading of 0 volts, then the problem lies upstream, either at the circuit breaker, in the wiring, or at another connection point. Thirdly, to test for continuity, which means checking if a circuit is complete, switch off the breaker and set your multimeter to the continuity setting. Touch the probes to the two ends of the wire you are testing. If the multimeter beeps or displays a value close to 0 ohms, then the wire is intact. If there is no beep or a very high ohms reading, then there is a break in the wire. When inspecting connections at receptacles, switches, and junction boxes, firstly look for loose wires, corroded terminals, and damaged insulation. Secondly, use a screwdriver to tighten any loose wire connections. Thirdly, if you find corroded terminals, clean them with a wire brush or replace the receptacle or switch. Fourthly, if the insulation on a wire is damaged, repair it with electrical tape or replace the wire entirely. Keep in mind that electrical tape is only meant to insulate wires, not to repair structural damage. Now let's discuss junction boxes in more detail. Junction boxes are designed to safely house wire connections. They are typically located in accessible areas such as attics, basements, or crawl spaces. Firstly, ensure that all wires within the junction box are properly connected with wire connectors or wire nuts. Secondly, make sure that the wire connectors are the appropriate size for the number and gauge of wires being connected. Thirdly, all junction boxes must be securely fastened to a structural element of the building, such as a stud or joist. Fourthly, junction boxes must be accessible, meaning they cannot be buried behind drywall or other building materials. If you find a junction box that is not accessible, then you'll need to relocate it to a more accessible location. Let's now focus on techniques for cutting into drywall. Firstly, before you start cutting, mark the area you want to remove with a pencil or marker. Secondly, use a utility knife to score the drywall along the marked lines. Apply firm, even pressure to ensure a clean cut. Thirdly, once you've scored the drywall, use a drywall saw to cut along the scored lines. Fourthly, hold the saw at a slight angle and use a gentle sawing motion to avoid tearing the paper facing of the drywall. If you're cutting a large opening, it is recommended to use a reciprocating saw, also known as a sawzall. However, use extreme caution when using a sawzall, as it can easily cut through wires, pipes, and studs. Firstly, always wear safety glasses and gloves when cutting drywall. Secondly, keep the saw blade perpendicular to the wall surface. Thirdly, use a slow, controlled sawing motion. Fourthly, avoid applying excessive pressure, as this can cause the blade to bind or kick back. Once you have cut out the section of drywall, carefully remove it from the wall. Inspect the area behind the drywall for any wires, pipes, or other obstructions. If you encounter any obstructions, then you'll need to carefully work around them. To locate studs, use a stud finder. A stud finder is an electronic device that detects changes in density behind the wall surface. Firstly, hold the stud finder flat against the wall and turn it on. Secondly, slowly move the stud finder horizontally across the wall until it indicates the presence of a stud. Thirdly, mark the location of the stud with a pencil. Fourthly, repeat this process to locate the other studs in the wall. The studs are typically spaced 16 inches or 24 inches apart, center to center. To check for wires and pipes, use a metal detector. A metal detector can detect the presence of metal objects behind the wall surface. Firstly, hold the metal detector flat against the wall and turn it on. Secondly, slowly move the metal detector across the wall. Thirdly, if the metal detector detects the presence of metal, it will emit a beep or display a reading. Fourthly, mark the location of the metal object with a pencil. Use caution when cutting near wires or pipes. Firstly, if possible, turn off the power and water to the area you are working on. Secondly, use a utility knife or drywall saw to carefully remove the drywall around the wires or pipes. Thirdly, avoid using a sawzall, as it can easily damage the wires or pipes. Fourthly, if you are not comfortable cutting near wires or pipes, then it is best to call a professional electrician or plumber. Now let's cover how to repair drywall. Firstly, cut a piece of drywall that is slightly larger than the opening you are repairing. Secondly, hold the patch over the opening and trace the outline of the opening onto the patch. Thirdly, use a utility knife or drywall saw to cut the patch to size. Fourthly, apply joint compound to the edges of the opening in the wall. Fifthly, press the patch into the opening, making sure it is flush with the wall surface. Sixthly, use a taping knife to apply joint compound over the seams between the patch and the wall. Seventhly, embed paper or mesh drywall tape into the joint compound. Eighthly, let the joint compound dry for at least 24 hours. Ninthly, sand the joint compound smooth with a sanding sponge. Tenthly, apply a second coat of joint compound and let it dry for another 24 hours. 11thly, sand the second coat of joint compound smooth. 12thly, prime the patched area with drywall primer. 13thly, paint the patched area to match the surrounding wall. When charging for troubleshooting, firstly, consider the amount of time you spent on the job. Secondly, factor in your expertise and experience. Thirdly, take into account the complexity of the problem. Fourthly, consider the cost of materials and supplies. Fifthly, be transparent with your customers about your rates and fees. Sixthly, provide your customers with a written estimate before you start work. Seventhly, be willing to negotiate your fees if necessary. It's acceptable to have a minimum charge for troubleshooting, regardless of whether you find and fix the problem. This covers your time and travel expenses. You can explain to the customer that troubleshooting involves a systematic process of elimination, and your expertise is valuable even if the issue isn't immediately apparent. Remember that effective troubleshooting skills are essential for any electrician. It involves a combination of knowledge, experience, and a methodical approach. Practice these techniques and always prioritize safety, and you'll be well equipped to handle a wide range of electrical problems. Firstly, always remember to document your troubleshooting steps. Keep a detailed record of the tests you perform, the readings you obtain, and any observations you make. This will help you track your progress and identify patterns. Secondly, use a process of elimination. Start with the simplest and most likely causes of the problem and work your way up to the more complex and less likely causes. Thirdly, be patient and persistent. Troubleshooting can be challenging, but don't give up easily. With enough effort, you'll eventually find a solution. Fourthly, learn from your mistakes. Every time you encounter a new problem, take the time to understand the underlying cause and how you can prevent it from happening again in the future. When working with electrical systems, safety is paramount. Always follow safe work practices and use appropriate personal protective equipment. Firstly, wear safety glasses, gloves, and appropriate clothing. Secondly, use insulated tools. Thirdly, never work on live circuits unless absolutely necessary. Fourthly, if you must work on a live circuit, use extreme caution and follow all safety procedures. Fifthly, always double-check your work before energizing a circuit. Sixthly, if you're not sure how to do something safely, then don't do it. Seek the advice of a qualified electrician. Remember, electricity can be dangerous, but with the right knowledge and precautions, you can work safely and effectively. When dealing with three-way switches, understanding the wiring is critical. Firstly, identify the common terminal on each switch. This is usually a different color screw than the other two. Secondly, the wire connected to the common terminal on one switch will go to the power source or the light fixture. Thirdly, the other two wires, called travelers, connect the two switches together. Fourthly, if the light is not working, test the voltage at each switch to determine if power is reaching the switch and if the travelers are working correctly. And fifthly, remember that three-way switches do not have an on or off position. They simply change the state of the circuit. Understanding the neutral wire is also very important. Firstly, the neutral wire carries the return current from the electrical device back to the power source. Secondly, it is typically white or grey in color. Thirdly, the neutral wire should be connected to the neutral bus bar in the electrical panel. Fourthly, the neutral wire should never be used as a ground wire. Fifthly, if the neutral wire is not properly connected, it can cause voltage fluctuations and electrical problems. Grounding is a critical safety feature in electrical systems. Firstly, the ground wire provides a path for fault current to flow back to the power source, tripping the circuit breaker and preventing electrical shock. Secondly, it is typically green or bare copper. Thirdly, the ground wire should be connected to the grounding bus bar in the electrical panel. Fourthly, all metal enclosures and appliances should be grounded. Fifthly, if the grounding system is not properly installed, it can create a dangerous shock hazard. Finally, continuous learning is crucial in the electrical field. Keep up to date with the latest codes, technologies, and best practices. Firstly, attend continuing education courses and seminars. Secondly, read trade publications and online resources. Thirdly, network with other electricians. Fourthly, stay informed about changes to the National Electrical Code. Fifthly, by continuously learning, you can improve your skills, enhance your knowledge, and provide your customers with the best possible service. The National Electrical Code, or NEC, is a comprehensive set of standards for electrical wiring and equipment. Firstly, it is updated every 3 years by the National Fire Protection Association. Secondly, it covers a wide range of topics, including wiring methods, overcurrent protection, grounding, and equipment installation. Thirdly, it is adopted by most states and local jurisdictions in the United States. Fourthly, it is essential for all electricians to be familiar with the NEC. Fifthly, following the NEC helps to ensure the safety and reliability of electrical systems. NEC Table 310.15b16 provides ampacity ratings for conductors. Ampacity is the current, in amps, that a conductor can carry continuously under specific conditions of use without exceeding its temperature rating. The table takes into account factors such as conductor material, insulation type, and ambient temperature. It is essential to consult this table when selecting conductors for electrical installations to ensure that they can safely carry the required current.